as a result of human-induced disruption of the balance of carbon dioxide in this world. Greenhouse gases are a result of energy, chemical processes, land use, stock farming, and fertilizer use. These gases in the atmosphere can trap, absorb, and re-emit red radiation from the sun.
Research questions: how does carbon storage of large trees compare to shrubs, saplings, and herbaceous plants? How do tree age, height, and DBH correlate with carbon storage? What is the link between vegetation biomass and carbon storage? How does yard vegetation, NPP, correlate with the biomass and carbon storage?
How does above ground and below ground carbon storage vary by ecosystem and methodology? And how does a household's carbon footprint compare to the ecosystem's carbon storage capacity? And what are its main contributors? We predict that large trees store the most carbon, followed by shrubs, saplings, and herbaceous plants. We also propose that tree age, height, diameter actively correlate with carbon storage. We believe that vegetation biomass positively correlates with carbon storage.
We propose that net primary productivity, or NPP, of the vegetation in our yard is positively linked to its biomass and carbon storage potential. We hypothesize that mature trees are the primary contributors to above-ground carbon storage, while dense herbaceous vegetation plays a greater role in below-ground carbon storage. Additionally, we predict that soil carbon storage will be as substantial as vegetation carbon storage at the residence. Lastly, we suggest that our personal carbon footprint will far exceed the vegetation's capacity to store carbon, with electricity usage being the main factor driving this disparity. We press into Globe Observer, choose Biosphere, create new observation, and select carbon cycle, and then start entering your location. Using Google Earth images, we identify visible tree crowns on the aerial map and compare them to the actual trees on the ground. So here, you want to choose Pedosphere and soil bulk density, then fill out the information required. Trees should have a height of more than 5 meters and a circumference of 15 centimeters or more around breast height. For shrubs and saplings, they should have a height of less than 5 meters and a circumference at breast height of less than 15 centimeters. For herbaceous protocols, it's dry mass, then put it into the allometric equations.
In order to find out the circumference, we times the diameter by pi and equate it into an allometric equation. We can find out the carbon storage by timesing the biomass by 50%, which is basically 1/2 of the biomass. And to find the carbon storage per sample site, we have to take the sum of all trees to be divided with the sample site area.
4 methods for soil carbon storage. First, soil characterization protocol, star soil moisture protocol, depth profile soil moisture protocol, and soil bulk density protocol. Then you estimate soil carbon storage, which is known as SCS, with this equation.
To estimate the soil carbon storage, we need to use the equation of the sum of the soil carbon density times the area of total grassland, and this is for each layer of soil. And in order to find the soil carbon density, you have to use the equation of the average bulk density of the soil times the percentage of organic matter of the soil times 0.58, which is the Bemelin factor, because approximately 58% of organic matter is soil carbon.
Rocky Black method is used to determine soil organic matter. Greenhouse gas emissions are categorized in 3 types. Scope 1, direct emissions from sources controlled by the entity, such as fuel combustion in machinery or vehicles. 2, indirect emissions from energy use, like purchasing electricity or other energy sources. Scope 3, other indirect emissions from activities not covered under Type 1 or Type 2. To calculate GHG, or greenhouse gas emissions, we use the equation GHG emissions equals GHG activity data times by GHG emission factors.
You can see 99% of carbon storage is from the big trees, and the net primary productivity in carbon storage has increased by 202 grams carbon per square meter.
We are able to see that there is a positive correlation between tree age's circumference, and also that tree carbon storage shows a positive correlation with biomass.
We can see that the soil in our area contains low to very low organic matter. Soil carbon storage ranges between 7,546 to 20,351 kilograms. We can see that below ground carbon storage accounts for approximately 30 to 54% of total carbon storage, and yet our carbon footprint exceeds the maximum potential by 10%.
As you can see here, this is the carbon emissions from these factors. We have 32% from air travel, 15.6% from car usage, 1.8% from water usage, and 50.6% from electricity. This means that electricity led the pack, compromising more than 51% of our carbon footprint.
In conclusion, we can increase our carbon storage by increasing planting of wood density trees, improving our soil to enhance carbon sequestration potential, adopting renewable energy sources such as solar rooftops, and transitioning to electrical vehicles instead of using fossil-based vehicles. And we could also prioritize green fuels for air travel. Thank you.
Thank you.